Find the open intervals on which the function is increasing or decreasing. The function is f of x equals 12x over x squared plus 4. When we are trying to find the intervals on which a function is increasing or decreasing, we need to find the derivative so we can find the critical values. The derivative of this function, if we want to find it, we will have to use the quotient rule. So that tells us that f prime of x will be equal to the denominator times the derivative of the numerator, and to that we were going to subtract the numerator times the derivative of the denominator all over the denominator squared. So now that we have this derivative, I would like to simplify it as much as I can before I set it equal to 0 and solve for x. So I'm going to distribute the 12 to the x squared and the 4, and I'm going to multiply these two terms together to get something like this: 12x squared plus 48 minus 24x squared all over x squared plus 4, the quantity squared. And the last step I can do here is to combine the x squareds in the numerator to get a final simplified derivative of negative 12x squared plus 48 all over x plus 4, x squared plus 4, the quantity squared. Now that I have this derivative, I want to set it equal to 0 and solve for x, as well as look for any undefined values that this derivative may have. So negative 12x squared plus 48 all over x squared plus 4, the quantity squared. I'm going to set it equal to 0. And if you look, there is a denominator that has an x. However, if you set this denominator equal to 0 to try to find any undefined values, you won't get any real numbers. They become imaginary. So we have no undefined values. So instead, we can just go ahead and start multiplying both sides by this denominator. So I want to multiply by x squared plus 4, the quantity squared. And over here, I want to multiply by x squared plus 4, the quantity squared. And what that does is that gets rid of our numerator, and that allows us to leave the right side of this equation as 0. So this equation turns into negative 12x squared plus 48 equals 0. And when you solve this for x, you will see that x equals plus or minus 2. So these are the only critical values that we have for our derivative. From the first slide, I have listed here the derivative that we found and the critical values that we found. And I have the critical values already graphed on a number line. And these critical values are what separate our number line into 3 different intervals. So we will have an interval from negative infinity to negative 2. There will be another interval from 2, negative 2 to positive 2. And there will be a third interval from 2 all the way over to infinity. So we're trying to figure out whether the original function increases or decreases on each interval. And in order to do that, we need to find a test value on each interval. So let's call this negative 3. Let's pick 0, and let's pick positive 3. And we evaluate the derivative at all of these test values. And if we get back something that's positive when we evaluate this, we know the original function is increasing. If we get something back that is negative, we know that the original function is decreasing. So let's find f prime of negative 3. This is equal to negative 12 times negative 3 squared plus 48 all over negative 3 squared plus 4 squared. When the numerator is computed, a negative 60 is what you get in the top. And when the denominator is computed, it will be 169. And this is something that is less than 0. So I will know over here that this interval where the negative 3 is contained will be decreasing. So in the answer down here at the bottom, I know the original function is decreasing on the interval negative infinity to negative 2. When 0 is substituted into the derivative in a similar fashion to when we did negative 3, you should find that you get something back that is positive. And that tells you that the original function is increasing on this interval. So down here at the bottom, I'm going to start an increasing interval from negative 2 to positive 2. And lastly, when you substitute positive 3 into the derivative, you will see that you get something back that is negative, which means the original function is decreasing on that final interval. So down here with the decreasing interval, I'm going to union in the other interval 2 to infinity. And here are the answers for where the original function is increasing and decreasing. The first derivative test states that if a function stops decreasing and starts increasing, that there is a relative min at that x value. The first derivative test also states that if a function stops increasing and starts decreasing, then there is a relative max at that x value. So we know there's a relative min at negative 2 and a relative max at positive 2. In order to find the y coordinates, you have to substitute in these x coordinates into the original function. And the original function is f of x equals 12x over x squared plus 4. And when you substitute these numbers in, you find f of negative 2. You end up with a y value equal to negative 3. And when you substitute in the value positive 2, you will get back a y value positive 3. So to turn these into ordered pairs, we will have a rel min at negative 2, negative 3, and a rel max at 2, 3. So here are the relative extrema for the original function.